Okay, so we're going to jump into section 1.6 of this textbook, the Springer textbook that you can download for free. But I'm going to go pretty close to it. So what is a permutation? A permutation is essentially just a reordering, or a way to order a set. So if we've got the set A, B, C, this right now is not ordered, but I can put the letters in a bunch of orders. A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. I can put it in any of these 6 orders. If I have a 2 set, say I've got the numbers 1 and 2, then I can only put this in 2 orders, 1, 2, or 2, 1. So a permutation is any of these orders. It's a way to reorder this set. And a natural question to ask is, how many permutations of a set are there? So if we want to know how many permutations of a set with n elements, and it only depends on how many elements there are. It doesn't really matter what those elements are. So here, if I replaced AB, 1, 2 with AB, then I would get AB and I would get BA. So it's going to be the same number. We can just map back and forth by assigning each element of our one set to another, or to an element in the other set. So how many elements, how many ways are there of doing it? So if we want to count for this guy, then there's 3 spots. And I have 3 options for the first spot. Now I can't pick that same option that I'd used for the first one for the second one. So that means I have 2 options for the second spot. And now I can't use those first 2 options for the third spot, so that means I'm just left with whatever's left. So 1 option for last spot. Similarly over here, I had 2 options for my first spot, but then once I picked my first spot, I was stuck with the second one, with what was ever left for the second one. So one way we can think of this is first spot. So we've got 3 options for our first spot. Let's say we pick A, B, or C here. Then for our second spot, we can't pick A again. So we have to pick B or C. And here we can't pick B again, so we can pick A or C. And here we can't pick C again, so we pick A or B. And then, each of these guys only has 1 offspring. So here we've picked A and we picked B, so we have to pick C. Here we picked A and C, so we have to pick B, C, A, B, A. So each one of these branches going down the tree corresponds to one of these lists, one of these ordered lists. So that is the tree method. And we can do that with a set of 4, and I'll do that with a set of 4, but I will stop after that because it just gets kind of annoying. But to give you guys a better visual intuition for what's going on. So if we got A, B, actually, let me erase these and give myself more space. B, C, D. So A has 3 options left. B, C, and D. B has 3 options left. A, C, D. A, B, D. And then we've got A, B, C. So then this guy, 2 options are taken, so it only has 2 options left, C and D. This guy, B and D. This guy has the 2 options of B and C. This guy has 2 options. 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 And then they'll each also have 1 more thing down the line. I'm going to fill in this guy. You guys, as practice, fill in the rest of this chart. So ABC, this guy goes to D, this guy goes to C, this guy goes to D, this guy goes to B, this guy goes to C, and this guy goes to B. And if you track everything out, that means we have 1, 2, 3, 4, 5, 6 elements on this first one. We're going to have 6 elements here and 6 elements here and 6 elements here. So we're going to have 24, which is the same thing as 4 times 3 times 2 times 1. So up here, this was 3 times 2 times 1. And each time we add a new option, we're just basically adding an additional first place, that is n plus 1 times n minus 1 times 2 times 1. So that means that if we have n objects, and we want all permutations of them, then there are n factorial possible ways to order them, or n factorial permutations. Or possible ways to order the set. Cool. So one way we can think of this is also that we are pairing up our order with an object, so A, B, C, D, last letter. And then you're figuring out all of the different ways that you could pair these. So this is one way, or this is another way, that you're figuring out how many different ways we can pair these 2 distinct sets. So that is another equivalent way to think of this. So if I want to know how many ways there are to pair these 2 distinct sets, with n elements. Each, then it is also n factorial. Because you can just map one set to this guy, and then it's the same thing as asking how many different permutations are there. So, and that's essentially what this is asking. So if there are n boys and n girls out to dance, how many ways can they all dance simultaneously, assuming that there are no mixed gender dancers? This class of problem used to be referred to as a marriage problem, and then the subsequent one of when you're allowed to map within a set to itself, that used to be referred to as a roommate problem. I don't know if that has been replaced with something given the changing social norms or not. So if n boys and n girls go out to dance, so we've got boy 1, boy 2, all the way down to boy n, and we've got girl 1, girl 2, all the way down to girl n. And we want to know how many different ways are there to match these guys up with the gals. How many different ways are there to do that? So that's essentially, we can put an order on the boys, and then we're just doing the same thing of mapping between 1, 2, 3, 4, all the way down to n with all of the different girls, or vice versa, however you prefer to think of it. So we have n options for the first one times n minus 1 for the second one, because whoever this first boy is matched off with, the second boy cannot dance with, times n minus 2 for the third boy. Again, times n minus 3 for the third or fourth boy, all the way down to 2 times 1 for the last few boys. So this is just n factorial. So how many different ways can 8 people play chess? In Alice's interpretation of the question. So basically, we have 8 people and we're trying to pair them off within. And this is a different type of question from this guy. So how many different ways? Actually, I'm going to stop this and then give that as a different explanation.